This is a fully functional air quality and climate monitor. It shows temperature, humidity, and real-time gas readings on a round OLED display, all inside a clean, enclosed, 3D printed shell. It has the weight and solid feel of a professional instrument, but the heart of a DIY project. No exposed wires, no messy breadboard, just a compact, finished-looking tool. But here's the strange part. Even though it looks like a finished commercial air monitoring tool, it isn't one. Everything inside this unit, the circuit board, the wiring, the enclosure, is designed to be made right on your desk. I call this little device the Aero-Node. And for an instrument this refined, making one is surprisingly straightforward. All you need is a basic 3D printer, or access to one, to build this at home from a few simple parts. This isn't something you buy, it's something you build. Behind this cover, the device is constantly sampling the air around you. The AHT20 or AHT30 measures temperature and humidity. The MQ series sensor, in this case an MQ2, detects smoke, alcohol vapors, and flammable gases. And the whole system is driven by the tiny RP2040 Zero, a microcontroller smaller than a coin. Fresh air flows in through the side vents, the sensors do their work, and the OLED shows everything in real time. It looks like a finished product, something you'd buy off a shelf, but it's not. If you've ever built electronics before, you might be wondering, where's the circuit board? Where do all these modules plug in? How is everything connected inside this enclosure? It's not like you can just print a circuit board at home, right? Well, that's exactly what you can do. Inside this unit is the secret, a 3D printed circuit board. It's a solderless, reusable board that turns 3D printer filament into functional infrastructure. No copper traces, no harsh chemicals, no lead solder fumes, just precision printed channels and 26 gauge wires. The wires click into place with a satisfying mechanical friction, no solder, no mess. You slide the wires into the printed slots, insert the module pins into the holes, and the whole thing becomes a clean, organized circuit that even a child could assemble. And because nothing is permanent, you can reuse every part again and again. The process is simple. First, print the PCB. It's designed specifically for the RP2040 Zero, the AHT series sensor, and the MQ series sensor, in this case an MQ2. Every connection, power, I2C, and analog, is already mapped into the printed channels. Second, wire it. Push 26 gauge wires into the slots. No soldering, no fumes, no burnt components. If you want a full step-by-step wiring guide, I've made a separate tutorial that walks through the entire process. The link is in the description. Third, mount the modules. The RP2040 Zero, the AHT20 or AHT30, and the MQ2 all plug directly into the printed sockets. And finally, attach the cover. A few screws hold the PCB inside the enclosure. The round OLED sits perfectly behind the circular window. And suddenly, you have a fully functional air quality and climate tool, built from parts anyone can buy cheaply online. To show the system working, I'm using an MQ2 sensor in this build. It reacts to gases like alcohol, smoke, and certain vapors. So for the demonstration, I'm using simple household sources. A small puff of methylated spirits or perfume instantly raises the reading, and you can see the value change on the OLED in real time. Even a quick breath across the vents shifts the temperature and humidity. The AHT sensor picks it up immediately. It's a simple test, but it shows how responsive the whole system is. Fresh air in, sensors react, and the display updates instantly. I designed this to be modular. If you don't care about air quality in your room but you want to detect smoke or alcohol, you just swap the sensor. Whether it's an MQ135, an MQ2, or an MQ3, they all share the same universal 4-pin layout. As long as the pinout matches, the board is ready. Just a heads up, this current version of the PCB is designed for normal indoor air. MQ sensors run on 5 volts, but the RP2040 Zero reads at 3.3 volts. In regular room conditions, it's safe and accurate, but avoid high concentration gas exposure that could spike the voltage beyond the microcontroller's limit. You can also use an AHT20, an AHT30, an SHT31, or a BMP280. As long as the pins follow this exact order: VCC, ground, SCL, and SDA. Some modules place these pins in a different sequence, so make sure yours matches this layout. This AHT sensor header uses 3.3 volts from the RP2040 Zero, so only use sensors that run on 3.3 volts. Some sensors are flexible. They can run anywhere between 3.3 and 5 volts, but many cannot, so always check the sensor's voltage rating before plugging one in. Between the MQ series and the AHT and BMP sensors, you can swap in whatever fits your project. This board isn't locked to one purpose. It's a universal host for your sensor ideas. It's not a fixed device, it's a platform. All the code for this unit, including the OLED layout and the sensor logic, is available on the project page on my website. You'll find the link in the description. You can flash the RP2040 Zero with the provided code and have it running in minutes. But here's the difference between this and a professional tool. Commercial instruments are closed. You get whatever interface they give you, whether you like it or not. This one is open. You can change everything. If you want the temperature in giant bold numbers or a real-time graph of the gas levels, the code is open. You're the lead engineer here. You can redesign the interface, add your own warnings, change the animations, or build entirely new behaviors. The hardware is printable, the wiring is simple, and the software is yours to shape. For this demonstration, I'm also using the RP2040 Zero's onboard RGB LED. I've written a small piece of code that changes the color based on temperature: below 26 degrees, blue; at 26 degrees, green; and at 27 degrees and above, red. It's a simple visual indicator, but it shows how flexible the RP2040 Zero can be. You can change the thresholds, the colors, or the behavior entirely. The code is yours to shape. And on the enclosure, there's a small opening for the status light, so you can see the color change in real time, even with the unit fully assembled. Traditional prototyping is fragile. Breadboards fall apart if you bump them. But this is a tool you can toss in your bag or mount on a wall. It's the bridge between a messy experiment and a finished product. With a 3D printed circuit board and a printable enclosure, you can iterate quickly. You can reuse every component. You can build real tools that look and feel finished, and you can do it all at home with almost no cost. This isn't just a project, it's a different way to think about electronics. If you like this project, I've made another one that uses the same 3D printed PCB approach, a dual screen instrument that can show system stats, weather, network speed, animations, or even a tiny digital character. The link is in the description, and if you want to know how this whole idea started, why I invented 3D printed PCBs in the first place, I've made a separate video that tells the full story. You'll find that link in the description as well. If you have a 3D printer, or even just access to one, you can download the STL files for both the circuit board and the enclosure, along with the code for the RP2040 Zero from my website. All you need are a few wires, a couple of inexpensive modules, and access to a 3D printer. And you can build your own air quality monitor that looks like a professional instrument. I've linked all the exact modules I used, including the correct round OLED, in the description. This node is part of the Vanguard Tier, a growing family of applied instruments. If you want to explore the other nodes in this tier, the links are in the description. If you want to follow the evolution of this system, consider subscribing. And if you know a fellow maker who would appreciate this design, feel free to pass it along. Thanks for watching. I hope this inspires you to try 3D printed electronics for yourself.